As you might recall, each routing protocol has a mechanism to determine the best path to a certain destination if there are several possible paths to that destination. Do you remember how different routing protocols determine the best path to a certain destination? The path with the lowest metric is the best path from the perspective of the routing protocol. Unlike other routing protocols such as RIP and OSPF, EIGRP does not use a single attribute to determine the metric of its routes. EIGRP uses a combination of 4 different features to determine its metric. These features are all physical characteristics of an interface. So what are these criteria based on which the EIGRP metric gets calculated? The criteria are bandwidth, delay, reliability, and load. Let's take a look at this formula to calculate the EIGRP metric. The formula consists of values K1 through K5, which are known as the EIGRP metric weights. By default, K1 and K3 are set to 1, and K2, K4, and K5 are set to 0. The result is that only the bandwidth and delay values are used in the computation of the default composite metric. So when using the default K values, the metric calculation simplifies to 256 times bandwidth plus delay. Now let's focus on these two criteria, bandwidth and delay. This is how the bandwidth gets calculated, and delay is computed as the cumulative delay end to end in tens of milliseconds. 2 additional criteria are used in the original formula, but are not recommended because they typically result in frequent recalculation of the topology table. The first criteria is reliability, which represents the worst reliability between the source and the destination. Reliability is determined with the help of keep alive messages. The second option criteria is load, which represents the worst load on the link between the source and the destination. Load is computed based on the packet rate and configured bandwidth of the interface. To verify all criteria that are used in the formula to calculate the EIGRP metric, you may have to use the show interface command. This way, you can actually see the actual values that are used for bandwidth, delay, reliability, and load in the computation of the routing metric. The output in the figure shows the values that are used for the composite metric for the serial 0/0/0 interface. You should note that a mismatched K value will cause a neighbor to be reset even if that value is unused. So always remember that K values need to be consistently configured throughout the network and only changed under the recommendation of Cisco. EIGRP metric K values are carried in EIGRP hello packets.